Alright, so now that we're done factoring and subtracting polynomials, we're going to talk about quadratic equations and using factoring to solve them. So kind of laid out just with a problem for you to get your brain going. So an artist has started a mosaic tile design on a wall. She needs to cover the entire wall. Write expressions to represent the length of the wall and the width of the wall. So the length's on the bottom, the width's out to the side. What could I use to represent the whole width of that picture? So hopefully you're saying width is x plus 4, length is x plus 6. So now area means you're going to take length times width, so I would do x plus 4 times x plus 6. And this is how can you determine the area of the part of the wall the artist has not yet covered? Well, I know it's got to be x squared plus 10x plus 24. So if we had the area of the wall, we could figure out what is the width and the length of the area that she hasn't covered yet. So really what I want you to think about is how would we solve that? Well, in order to solve it, we solve it using something called the zero factor property. So notice this is a factored problem. See how it's factored in its two parts, 3x plus 4 and x minus 5. But notice it equals 0. So beforehand, we didn't have the equals 0 part. We just said 3x plus 4 and x minus 5 factored equals, we didn't have an equal sign. So now the zero factor property, which is what we're going to use, if I have a quadratic equation, I set it equal to 0. So I take each individual part and I set it equal to 0, and I would solve them individually to get my two answers. So the first one, I had 3x plus 4, I set it equal to 0, I would subtract 4, and I would divide by 3, so I would get x equals negative 4 over 3. The second one, I would add 5, and so I would get x equals 5. Now think about this, if I plug in 5, that would give me 0 here. Well, what's 0 times anything? It's going to be 0, so that's why the zero factor property works, because I know if I get 0 in one of those parentheses, and then I multiply by the other one, I'm going to get 0. So it says, how can you find the solution of the equation? We just talked about it. You just use the zero factor property. So I'm going to take x minus 9 and set it equal to 0. I'm going to take 5x plus 2 and set it equal to 0. So I get x equals 9, or x equals negative 2/5. So those are your two answers for the solution of the equation. So go ahead and take the time, pause the video, try and solve 1a and 1b down here, and figure out how can I find the solutions of this. So we're going to use the zero factor property. So hopefully you got 1/2 and negative 3 for the first one, because I would say 2x minus 1 equals 0, or x plus 3 equals 0, and then I would solve it. So the first one I added 1 over, and I divided by 2. The second one I just subtracted 3. I got x by itself. The next one I would get negative 3/2 or 1/3. Hopefully that's what you got. Again, I would set each one individually equal to 0, so I would say 2x plus 3 equals 0, and 3x minus 1 equals 0, and then I would solve it. So that's how you find the solutions if it's already factored. Now, what if it is not factored? So, the general form for a quadratic equation, right, it's going to be ax squared plus bx plus c, and normally our y is going to be a 0. That way we can solve it using the zero factor property, normally. And so the a is going to be a number, the b is going to be a number, the c is going to be a number. The x squared and the x are going to change depending on the letter, but most of the time it's going to be x's. So it says, how can you use factoring to solve x squared plus 9x equals negative 20? Well, remember, the goal here is I want it to equal 0. So this doesn't equal 0, so I need to add 20 to the other side. And I can't combine it with anything because it doesn't have an x attached to it or an x squared, so I can't combine it with the x squared or the 9x. So now it looks like this. X squared plus 9x plus 20 equals 0. Well, this is a quadratic equation now, and I can use factoring to solve it. So we've factored these before. So if I did x squared plus 9x plus 20, I'm looking for what multiplies to 20 but adds to 9. So it's got to multiply to the last number, add to the middle. So if you think about that, I list out the factors of 20. I get 1 and 20, 2 and 10, 4 and 5. Well, 4 and 5 adds up to that 9 in the middle. So the factored form would look like this. X plus 4, x plus 5. And now we're going to set it equal to 0. So then it says, all right, what are the solutions? Well, that's what we just did. I take each one individually, and I set it equal to 0. So we get negative 4, or negative 5. So go ahead and solve 2a and 2b. So again, pause the video and try those by yourself. So in this one, what multiplies to 64 but adds to 16? Well, that's x plus 8 and x plus 8, because 8 is the one that multiplies. Pair of 8s is the one that multiplies to 64 but adds 16. I would set each one individually equal to 0. If you notice, you get the same answer. You get negative 8 on both of them. So you really only have to write it once. You don't have to write it twice. But I know it's got to be negative 8. So again, same thing. This time it's multiplying to a negative 64. It's got to add up to a negative 12. So that would be 4 and negative 16. So I would say x plus 4, x minus 16 equals 0. Set each one equal to 0. So I either get negative 4 or 16. So then it says, how can we use factoring to solve 2b squared plus 17b plus 21? So the ones before were all easy factoring. Well, don't forget, we still have the AC method if there's a number out front. So 2b squared plus 17b plus 21 equals 0. I would have to do the AC method, so I would do 2 times 21, which would give me 42. List the factors of 42. So which pair adds up to 17? Well, that's 3 and 14, so now I'm going to rewrite it. So then I group the first two and the second two. The first two only have a b in common. The second two have a 7 in common. So then I'd write my final answer, b plus 7, 2b plus 3. Now, if I wanted to solve it, right, I'm going to set them equal to 0. I'm going to solve them. So the first one would be negative 7, or we get negative 3 over 2. So go ahead and try these next two. And again, you only have to do AC method if there's a number out front, in front of the square. Now this one's a little bit harder because before you even do the AC method, you should factor out a b. So then I would do the AC method with this. So 3 times 2 would equal 6. But it's got to add to -5, so I made them both negative. So I would say 3b squared minus 2b minus 3b plus 2. Factor by grouping. Now notice on this one there's a b on the outside, so I would set it equals 0, but you really don't have to solve anything. So I would get 0, 1, or 2/3. And again, that's because I factored out a GCF of b, right? If it was just a number, you wouldn't have to set it equal to 0 because it technically wouldn't be a true statement. But because it's a b, you just set it equal to 0 and you don't have to solve anything. You know it's got to be 0. So that one I would have 3 answers. So then lastly, got to move the 3k over, and then I got to do the AC method. So you know it's going to be -4 and 7. So then I would set them equal to 0. So again, these are just kind of some more advanced problems, some challenge problems. I really want you to understand how can I do these ones, so the symbol factoring ones, and how can I do the zero factor property to solve it. That's the key things. Are you going to do the AC method? Maybe occasionally, but not a whole lot. All right? So just keep that in mind when you're solving these problems. And if you guys have any questions over it, please let me know. Your homework should be a Pearson assignment. If not, it'll be a paper assignment. We'll put it in the Google Classroom, so make sure you check that. Otherwise, have a good day. Please check in if you are struggling, okay?